Hello everybody, welcome to Unit 4. We're talking about work and machines in this unit. We talk about our first topic, work, in our first video. A little bit different format. We're going down to one slide per video, less than 5 minutes hopefully. Deal with one topic at a time. So hopefully you have your new template and you can do the reading associated with it. Alright, first thing we want to do is define what work is and calculate how much work is done. All right. So when we define it, we're talking about work is the product of force and distance. Now, what physics did is they took a word that people have used for a long, long time and they said, all right, how do we describe when work is done? Well, you need to apply a force and you need to move the object a certain distance. And when we multiply force times distance, we get work. So that's our definition of work. Okay? So when we think through this definition, we see that work requires motion. In class tomorrow, what we'll do is we'll look at different examples of when you're doing work and when you're not doing work. Okay? I can push and pull on something all day, but if it doesn't move, then no work is done. All right? So if I go and lift a heavy box, all right, pick it up off the floor and move it to the table, the box moved, I've done work on the box. I exerted a force on the box. That force from my arms, that applied force, moved it from the floor to the table. Therefore, work was done. The force was from me on the box, so therefore the work was done on the box. That force needs to work in the same direction as movement. So I pulled up, the box moved up, therefore it was my force which moved the box and did the work on the box. Now, this direction of force is going to be important. All right, so work is going to depend on direction. And we learned earlier in Unit 2 that forces are vector quantities, which means they can be added, subtracted, combined, and that direction is important. We saw that when I add up or combine vectors, I get a resultant vector. Well, now we're going to do the same thing but in reverse. We're going to take that resultant vector and break it down into its component parts. Which part of that force is up and down, vertical, and which part of that force is left and right, or horizontal. Right? Because any part of that force that doesn't act in the same direction of motion isn't doing work on the object. Only those components of force, only those forces, or those parts of forces that are in the same direction as the work being done count towards that work. Okay? So very important. Definition of work, we know work requires motion and work is dependent upon direction. So now, we're working with simple equations. What's our equation for work? Work equals force times distance. Often abbreviated as FD. Work equals FD. Now, what are our units going to be here? All right? Think about it for a moment. What are our units for distance? How far apart are you from your computer? Half a meter? Okay. Meters are units for distance. Okay. What are our units for force? Units for force are newtons. So I take a newton times a meter and I get a newton meter. Well, we have abbreviations for that. We call a newton meter a joule. It's abbreviated with a capital J. And so we see that 1 joule is equal to 1 newton times a meter, a newton meter. It's kind of hard to say, so we call it a joule. But if we want to expand that a little bit, what is a newton? A newton is a kilogram meter per second squared times a meter. All right? Here's my newton. There's my newton. Here's my meter. There's my meter. So what is a joule? A joule is a kilogram times a meter squared over a second squared, or a newton meter, or a joule. Okay? The basic international unit is joule, but if we unpack that, it's a newton meter, or a kilogram meter squared per second squared. We're going to keep it simple with the math. We're going to do sample problems in class tomorrow. All right, make sure you get your reading done, pages 412 to 414. Write down what you heard, write down any questions, do your reading. We'll see it in class.